So, okay, let's actually run non-asynchronous version and we can connect to it. As you can see, it is responding. We can connect to different clients and it is responding as well. But look, the problem here is that it creates two separate threads. And every time I do another connection, it creates another freaking thread. But now let's take a look at our asynchronous version. Let's kill this shit and let's put asynchronous true. Let's actually run it and I can connect to that. It responds to any of my queries. I can connect another one. I can connect another one. And all of them are responding. Nothing is blocking. Everything is perfect. But look at that. There's no additional threads in here. It's all handled within a single thread because we're using asynchronous sockets. All right, let's get started. Hello, everyone, and welcome to another creation programming session with Mr. Zodin. So today we're doing an offline session because I'm a little bit tired of, Twitch distractions. So, as you know, I'm developing my futures libraries in C3 because C3 doesn't have one, right? So it's a language that is currently in development, so it doesn't have a lot of things. If you want to have some things, you have to develop them yourself like a real programmer. I need more examples for this library, right? And one of the examples I want to introduce is Echo Server, right? So Echo Server is essentially just a server that listens to incoming TCP or UDP connections, and the clients may send some data, and that server just sends that data back. Right, it's a very simple application, and I wanted to have that, but with the futures libraries, right? So futures usually are used for asynchronous programming, right? And I think I wanted to, I want to take it as an opportunity to demonstrate the differences between synchronous programming, synchronous network programming, and asynchronous network programming. I think it's going to be interesting. So let's go ahead and just like introduce an example, right? So C3 Fute. And I'm going to create Echo C3. So, and this is going to be the, Echo server. So first of all, let's create a hello world, right? So just to test things out, I'm going to create an entry point. And within the entry point, we're going to say print fn hello world. So recently I started to finally use the built-in build system of C3, which is basically a project JSON. And it's very straightforward, right? So you can have targets, and the targets can be of different types, either executable, static library, dynamic library, and you have sources, right? So you can also add new targets either manually by modifying JSON, or there is a special subcommand for that, right? So you can do project, add target, and let's add target echo, which is an executable target, and one of the source codes for this example is going to be echo C3, right? And what it does, it literally just modifies your JSON and it just adds this entire thing. So then later you can do C3 build echo, and it just builds that specific example. You can also run it right away, and as you can see, it's a hello world, right? So you can also put additional flags in there and stuff like that. It is honestly, it's rather limited for my tastes. I haven't figure out how to do more complex actions in here, right? So far what I can see is that it just builds executables, right? But what if you want to do some more complicated stuff, right? So what if some of the targets in here depend on other targets, right? So what if maybe I want to create an executable that generates some sort of a resource file that I then want to link with other things? It's really unclear how to do that within this build system, but maybe I just haven't figured it out. Or maybe it's not even, it's not really developed to that point yet. Maybe it is in plans. I don't know. Right, so, I mean, it's usable for simple things, but I don't really see it how to use it for more complex stuff. Right, but anyway, so it actually doesn't really force you to develop in any particular style. You can use whatever you want. You can always actually build things outside of that build system, which is good. I really appreciate sort of like giving options to the users. So anyways, let's start with implementing maybe a synchronous Echo server, right? So we're gonna start with listening to a TCP to a TCP port. So let's actually find how to work with TCP. So I remember there was a TCP file somewhere in stdnet TCP somewhere here, right? So, and we can essentially listen to a specific host and specific port, and backlog, I suppose, it's basically an option that tells the operating system the size of the queue of the connections, right? So essentially when one connection is waiting, right, another one goes into the queue and waits until the previous one is actually finished. And this is one of the drawbacks of the synchronous programming, right? It's kind of difficult for you to you know, manipulate several connections, right? Unless you do multi-threading, but we'll go to that a little bit later. Right, so let's actually go ahead and try to listen to a specific port, right? So we probably need to first import net TCP like so, and just do TCP listen. And we're listening to specific host. Let's actually listen only to local connections, to the port 6969, and let's have 69 people in the queue. Right, and this thing obviously can fail, right? So, and let's actually unwrap it automatically. So that means if this call fails for whatever reason, this thing will unwrap it and panic it like in Rust, right? But this is not Rust, this is actually good language. So, and this thing will return you the server socket, right? So let's actually call the server. There we go. And after that, what you have to do, you have to keep accepting things, right? So you have to keep accepting things, and it will give you the client socket. So you usually do that in some sort of a loop, right? Like this. And it's not even a method of this thing, right? That's kind of bizarre. Could have been a method, honestly, but whatever. Accept. Like so. It can also fail, obviously, and this gives us the socket, the client socket, like so. And I feel like another thing I forgot in listen, actually, I think I literally forgot it. In one of the socket options, so we need to be able to reuse addresses, because one of the annoying things in TCP is that if you close the socket incorrectly, you won't be able to use this specific port for some time, right? So you'll have to change the port. But there's a special option that overrides that annoying default behavior. You know, the classical situation when you have an annoying default behavior that nobody likes, so you have to go out of your way to actually change it. The classical situation of shitty defaults, but maybe, I don't know, I understand that maybe it is needed sometimes, but in the majority of situations I have to turn this option on. That means maybe it have to be default, right? So, and if you need a different behavior, just make that an option. I don't know, right? So I think it's called reuse, yeah, reuse address. So that's basically what it is called. Maybe there are good reasons for it to be like that. I don't know. You never know. You never know. All right. So, and essentially accept will block until somebody connects to the port 6969. We can even test it out, right? So we can do something like print fn OK, right? So, and then we can close this entire thing and go to the next connection. So let's go ahead and just try to run this entire thing. Obviously it doesn't compile for whatever reason. It does, yeah, so I have to unwrap this thing as well, because close may fail as well, right? So in this thing, oh, and this thing will never be executed, right? So it's unreachable code, and unreachable code apparently is an error in C3. Okay, whatever, you want to make it an error, let's make it an error. Right, and it's gonna just basically stay like that until you try to connect to a port 6969, and as you can see, we connected and the connection was instantly closed, and we got okay, so we can connect it one more time. Right, so that's basically what it is. So after we connect it, we may try to read something, right? So let's go ahead and do that. We can do read. And if I'm not mistaken, read is defined somewhere here. Yeah, there we go. So you need to have some sort of a buffer, right? A limited buffer of bytes into which you're reading things. So let's actually allocate that buffer, right? So let's actually allocate 100 kilobytes, right? So this is the buffer, and let's read a little bit, right? And read, if I remember correctly, returns you how many bytes it read, right? So let's actually save it in here. And obviously it can also fail. Right, I don't really remember how it can fail. I think it may fail with a broken pipe or anything, but whatever. So, and in case of, you know, finishing the connection, if the client closed the connection, I think n is going to be 0, right? So, and after that, we may want to basically print it on the server side. Let's actually just inspect whatever the client sent us, right? So before sending it back. So we can say client sent this, and then we need to take the buffer, and we need to take a slice out of that buffer, right? So let's actually do something like this, right? So here we say that the slice starts from 0, and it has a length of n, right? And so then we are interpreting it as a string. I think I have to explicitly cast this thing to string, otherwise it's going to print it as a character array, but let's actually see. Maybe I don't have to do that, I don't remember. So that's kind of the problem. But we can always test things out, right? So we don't have to be 100% sure. You can always test things. That's the beauty of programming, right? You don't need to remember a lot of useless information. You can just test things, right? So telnet localhost 6969, and we're gonna set some data. And as you can see, it actually didn't print it as a string, it printed as an array, which is a little bit annoying, but I mean, that's fine. So we can actually explicitly cast this entire thing to string, right? So let's actually restart the whole thing. And if I send hello, it actually says that the server sent hello, probably also with a new line or something, right? But I'm not 100% sure why it sent the new line in here. Yeah, so it kind of included the new line. Did it include the new line in the character array? So let's actually remove the string. All right, so then I'm gonna go in here. I'm gonna restart. So we sent some weird shit. Right, so I'm gonna say hello and 1310. That is that /r/n? I think it is. I think it's literally /r/n. printf/r/n xxd. Yeah, it's 1310. Okay, so it's probably something that Telnet actually sends. Okay, I see. So it's probably something that Telnet sends on, you know, each enter, right? So because Telnet is not just like a for general TCP connection, it's a very specific thing, right? So maybe we could have just used netcat in this specific case, right? Can I do, you know, localhost 6969, right? So, but it didn't work, right? So maybe I could have just do echo hello and just pipe it into here. It didn't work. Okay, whatever. So I'm gonna stop experimenting. It doesn't really matter that much, right? So I'm just trying to understand the tools that I'm working with. So, and essentially after we read this entire thing, what we want to do, we want to send it back, right? So we're gonna do client, just to write that thing back to the client. Right, so there we go. And that should be it. So I think it will also return an error, so we have to account for that. So, and if I do something like telnet localhost 6969 and I send hello, it sends hello back and actually closes the connection immediately. So it's not particularly convenient, right? So let's do the following thing. Let's let the client close the connection, right? So let's maintain the connection until the client closes the connection. So we're gonna do something like while true, nested while true, by the way, right? Nested while true. And essentially in here, we're gonna read some buffer and send it back. And I suppose we wanna quit the entire thing when n turned out to be 0, right? So we're gonna actually break out of that inner loop. Right, and here we're going to close the connection. So that way, as soon as the client closes the connection, right, we're also going to close the connection. So I think we need to log a little bit, right? So because it's going to be unclear what the fuck is going on. Let's say client connected, right? And in here, we're going to say client disconnected. So, all right, so let's actually try to run this thing. And I'm going to try to run this stuff. Telnet localhost 6969. Hello, we got hello back. World. We get the world back. So to close the connection in Telnet, if I remember correctly, you have to press this escape sequence, right, like this, and it goes into the console or REPL where you can say close the connection, and as you can see, the connection was closed and the client got disconnected. Everything is fair, as you can see. All right, that's pretty cool. But there's a little bit of a problem with this entire implementation, is that if you connect it once and you want to connect a second client simultaneously, you're going to have a little bit of a problem, right? So 6969, and as you can see, it doesn't respond. It doesn't respond because the network in here is synchronous. So until we closed the connection in the first client, we don't even receive anything from the second one, right? So the server can only work with one single connection. And that's the huge problem, right? So because it's an internet, right? So you're supposed to work with several clients. So there's millions and billions of devices. How are you supposed to work with them? So the easiest fix for this specific thing is probably to add multi-threading into the mix, I think, right? So that's the easiest thing to do in here. So just like take this entire thing and run it in a separate thread. So, and C3 does in fact have multi-threading in the standard library. So let's actually take a look. So I think it's somewhere in std threads, and yeah, there's a thread C3. So what you're supposed to do, I think you're supposed to create a thread structure, or maybe I remember where is the thread. Yeah, so here it is. Yeah, it's just like an internal native thread, right? And then you have a method create that, given a thread function and an argument for the thread function, just creates the and starts the thread. Okay, let's go ahead and do that. So yeah, when we connect it, we want to do thread, client thread. So, and obviously we probably want to actually include thread in here, right? Otherwise we won't be able to use it. So, and we just create it, right? So we just allocate it on this stack. Then what we need to do client thread create, and it accepts thread fn function, which is defined like this, right? So that's the signature of the function. It returns an integer, probably indicating error or not, and accepts an argument, which you can also provide to the create arg. So essentially, whatever argument you put in here is going to be passed into this function, and this is because C3 doesn't have closures, right? So essentially, if you want to pass some information to a particular higher order function, you have to pass it like manually like that. But you can then think about this argument as the closure, right? So you're still doing closures, but kind of manually, right? So because I suppose the justification for not having closures is in C3 were that it complicates keeping track of lifetimes and stuff like that, right? So which is understandable, right? So learner is trying to keep the language rather simple. So I want to move this entire logic somewhere here, right, into a separate thread. So as soon as you created that thread, it is going to start. Right, but then you need to wait until that thread has finished and deinitialize it. Like recently, actually, Twitch chat taught me about a very cool concept, which is detach. Right, so I think it is related to pthread detach. And essentially, it marks the thread identifier by thread as detached. When detached thread terminates, its resources are automatically released back to the system without the need for another thread to join with the termination thread, right? So this is something that we want to do in here because we don't really care about receiving the result of this thread, right? So we just want to fire and forget, right? And listen for the next things. So, and essentially what I'm going to do in here is just a thread and detach that thread. I think it can also fail, right? So let's actually unwrap it. So the code in C3 is very screamy, as you can see. It's very screamy, but this is because we're not trying to propagate the errors in here up or handle them, right? So we just want to panic on them, and that's why it's screamy. If it was not in the root of the program, in the entry point of the program, I think it would have looked slightly differently, but whatever, it doesn't really matter. It's not really that noisy syntactically, if you think about it. So anyway, right, so we just do that, but I feel like we also need to allocate the buffer within the thread, so each individual thread has its own buffer. Right, and I think that's about it. So let's actually try to compile this entire thing and see what kind of compilation errors we have in here, because I'm pretty sure I made some mistakes. Okay, so looks like I did it first try, but I mean, I want to build echo. Yeah, so here are the errors. So yeah, client is not visible in here. Client is definitely not visible in here because we don't have closures, right? You can't access this variable from here, you need to pass it. So we can actually pass it as an argument, right? So essentially what we can do, we can just say, okay, client, and pass it as a pointer, right? So this is a void star. Right, but since client lifetime is only one single iteration, as soon as the thread started and the loop went on the next iteration, this pointer will become invalid. So I suppose one of the things we want to do is to maybe copy that TCP socket locally, right? So it's going to be client, and we're going to cast that TCP socket to a pointer, right, like this, and then dereference it and copy it into here. But I mean, it's kind of dangerous. Like it depends on timing, right? What if we didn't have enough time to actually start the thread and it already went on the next iteration and this thing already became invalid? One of the things we can do in here is probably maybe put it into a dynamic library in that case, right? So we can just maybe, you know, clone, right? So there is a very cool macro in here in C3, which accepts a value, allocates memory big enough to fit that value in the dynamic memory, copies that value into the dynamic memory, and returns you a pointer. So you basically can just like take a value on a stack or somewhere and move it into dynamic memory, right? So it's called cloning here. It's very useful for this kind of situation. So we're moving the dynamic memory, passing it to a thread. So, and now within the thread, maybe we don't even have to copy it, right? So we basically treat it as a pointer in here. But then one of the things we should not forget is to basically clean it up. Or we can do something like defer free client, right? Like this, right? Defer free client. Honestly, we could have actually done like all of these things in a defer, right? So basically free the client, then also maybe first close the client, free that client, and print that the client connection was closed. I think that's actually rather nice, right? So all of that is going to be you know, implemented, like executed at the end of the function. All right, so that's about it. It would be kind of cool if this thing returned the thread so I can immediately detach it, right? So is that something I could do? I wonder, let me actually see. So create doesn't really return anything, it returns a void. Yeah, it would be kind of cool if it literally returned self. Yeah, but anyway, whatever. So we could chain them, but it's a purely syntactical, you know, thing, opinionated syntactical thing. All right, so let's try to build this entire thing, and obviously it doesn't build. Right, because we don't need to we don't need to dereference this point. We can just keep it as a point. And by the way, I can actually syntactically keep it like this. There we go. Right, so unlocalized error missing return statement at the end of the function. It didn't even tell me where exactly that happened though. That's probably a bug. Oh yeah, so it has to be return 0 in here, I think. Yeah, so something, maybe there's some sort of a bug. It didn't tell me where exactly that happened, so something is weird going on. Right, anyway, so usually C3 actually tells you where things, where the errors happen. So let's do telnet localhost 6969, right? So, and here we have that thing and hello world. And now I can connect to the second one, telnet localhost 6969, and I can do test. And as you can see, it returns things. I can put this stuff in here, this stuff in here, and I do receive, you know, the responses, right? And I can now work with several clients simultaneously. So the problem is solved, right? The problem is solved. But so there is another problem in here, is that for each connection, you create a separate thread. I can even demonstrate you, I think, right? So if I open htop and search specifically for the echo, right, you can clearly see what is going on in here, right? So as you can see, here is the main thread, main application, and here is 2 connections in here. And now every time I'm creating a new thing, a new connection, telnet localhost 6969, it will create a separate thread, as you can see. And for each connection, it's going to create a separate thread. So if I close one of the clients, it removes that thread. So what if you have 10,000 connections? So it's going to create 10,000 operating system threads. Right, and usually, I mean, I suppose operating system will try to schedule these threads each per core. So do you need to have like a 10,000 cores to actually handle all of that efficiently? It feels like a huge waste of resources, honestly, like creating an entire separate, effectively process, right? So because threads are processes that share the memory, right? That's what they are. Creating separate threads, a separate operating system thread per connection is a huge waste of resources, especially considering that the majority of the time application doesn't really do anything. That's the thing. This Echo application right now, it literally does nothing. It doesn't compute anything. It doesn't even need processor right now. That's the bizarre thing, right? So the only thing it does is waiting for I/O. Right, and because of that, usually when people write like a very intensive networking applications that don't do a lot of computations, they don't use this approach. Like very few people use this approach. It is easy to implement, right? It is very easy to implement. You just slap threads together and there you go. But people rarely do that. And honestly, once you introduce threads, there is a lot of problems with synchronizing the threads or sharing some data between them, right? So that means you need to start like using critical sections, mutexes, and stuff like that. And it's a huge pain in the ass, like out of nowhere. So instead of that, people usually do what? They usually do asynchronous networking. Essentially, the thing about synchronous networking that we're doing in here is that each call in here accepts right, listen always blocks, but accept, read, and write, they block until they finish. And that's why we need separate threads, right? So to do these blocking things simultaneously, so if they block, they only block a different thread, not the current main thread. So they're all blocking. You can actually mark all of these things as non-blocking, right? So essentially here is the server. I can take its socket and I can set non-blocking, right? And what this thing does, for example, if I did that on a server, that means this accept will never block. It will never block. Let me actually demonstrate you, right? So I'm gonna just remove all of that code, right? Simply remove all of that code. And in here, I'm gonna go into, client connected, and then we're gonna just return 0 in here, or maybe just the break, right? So let me close all of these things in here. I don't think they're needed for our demonstration. So I'm going to close this entire thing. Right. So if I restart this entire thing is blocking until I connect it. As soon as I connected, we unblocked. Right. And we went out of the loop and we just exited. So if I make it non-blocking, it will not block and continue executing. Right. So let me actually restart it. Yeah, there we go. It failed with accept failed. So if it is about to block, it will fail instead and continue executing. That way it tells you that accept didn't have any pending connections. So what you have to do, you have to try it again later. Maybe later there will be more connections. It is useful for when there is no connections and you don't do anything, you're just waiting. While you're waiting, you might as well do something else. Right, so within a single thread, right, so one of the things you need to do, you need to accept connections. You check, is there any connections? Okay, there is no connections, I'm gonna go do something else. This is why it is implemented like that. So there's a little bit of a weird design of error handling of a C3 standard library, right? It's not supposed to return you accept failed connection. It's supposed to return you an error which is called would block, right? Not would block, but would block. Right, it's a common POSIX error, specifically POSIX error, which different I/O functions return instead of blocking. Right, so essentially it tells you, I would be blocking at that call, but since I'm marked as non-blocking, I didn't block, so I would block. Right, that's how asynchronous programming is done usually, right? So you do a blocking connection, but since you're not blocking, it didn't block, but you need to know that it would block. There you go, would block. And essentially there is a little bit of a problem here. It's supposed to return would block, but it didn't. Let's try to take a look at the source code of this TCP accept. I think I do have, yeah, TCP C3. So here is an accept. Yeah, there we go. This is because it tries to do low-level accept, which is the accept of the operating system. And if the socket returned by accept is invalid, it just forcefully returns accept failed. Right, and I don't really know the justification of why it was done like that, but some of the other functions just return you this specific socket error. Right, and essentially what we can do in here is to grab that error, don't unwrap it, just store it like that. And if we have an error, right, so the client error, we can try to actually fail with that specific error instead. We can do OS socket error. I don't really remember where can I get an OS. I think it's a net OS or something like this. Maybe just net, but it's located somewhere. We'll figure it out eventually, hopefully. Maybe OS like this. So OS socket error, so it returns us an error, and I suppose we can just unwrap it like this. I think we can. So yeah, maybe even turn it into an error and then unwrap it like so. Okay, so let's try to run this entire thing. And it failed with would block. Right. So ideally, I think the standard library of C3 should simply return, do the same thing as here, just return the socket error. But for some reason they added additional layer of this thing, and now you have to directly check this socket error. I don't know, I spoke to learner and he said that this thing needs to be reworked anyway, so because it's a little bit weird. So it's sort of like the thing that needs to be fixed in the future. But anyway, so we can get an exact error and we can know that this thing would block. And essentially what we have to do now, right, so we should listen for one of the connections, and if there is no other connections, we need to process the reads and writes of the current sockets. That's what we have to do. So that's kind of the point of the asynchronous connection, and this is where futures can help us. Right. So I really recommend to actually watch the previous stream on futures. The playlist to this series is going to be in the description, right? And essentially future that we developed in here, it's a very simple interface with a very simple method, which is called poll, right? And that's where you sort of like check whether a specific piece of work is finished or not. So usually an environment provides you some data, right? In our case, it's going to be the socket from which we are reading things and stuff like that. And you're supposed to return any, and any in C3, by the way, is a nullable value. You can think of any as a struct with a pointer and a type tag. I think it's a type ID or something, right? And essentially it can hold any type, and it also holds information about the type it is currently holding, right? It's sort of like a thick pointer. Right, and it could be nullable, right? So you can assign null to it, and by returning null, you indicate that the future is not finished yet. As soon as it finishes doing its work, it returns you something. It returns you value in the form of any, right? And since it has exclamation mark, it may also return an error, right? So it basically decodes 3 outcomes of the poll, right? Any as null is pending, right? So we're still doing some work. Right, we're still, for example, waiting for connections. The non-null any is the work is finished, and exclamation mark means that something went wrong, an error was thrown to future. You should stop polling it and maybe print an error or maybe recover from the error. You have to do something, right? So because futures may fail, in fact. So that's the future, and we have different kinds of futures. We have an example actually here, one of the examples. So we can have a counter, right? So this is a counter future, which has the current index and for how long it wants to count, so upper bound, right? And essentially poll, every time you call poll, it increments the counter, right? It increments the counter. So we also implemented a bunch of other features that allow you to chain things like then, right? So it accepts, you know, one future and then function that takes the result of the future and then creates a new future based on that. So it's sort of like a monadic operation on futures, right? So yeah, I'm an ex-Haskell developer, so I just implemented monads in C3. So yeah. What can I say? Haskell permanently damaged my brain. But anyway, it's actually rather convenient. It allows you to write code like this, right? So we have a future done, which is always done. So essentially, when you call poll on that future, you instantly get the value that you put in here. So it's a future that is always done. So, and in here, I chain that future with a thing that prints the value and schedules another future. And then I chain it with another one and another one and another one. And if it at any point it fails anywhere, right? So I'm basically catching that value, right? So, and we have an example on how you work with that. So I have a counter and a huge chain of futures. And I demonstrate how you can actually run these things simultaneously, right? So this feature is supposed to just sequentially print 69, 420, 1337, right? Then it will throw an error, right? And then it will recover from that error. And then we have a counter from 1 to 10. And all of these things should run simultaneously in a single thread, right? So, and we can even demonstrate that. I can do run example. So there you go. So we have 1, 2, 3, 4 simultaneously, and also 69 for 20, 1337, and also recovery, and so on and so forth. As you can see, so this is two sort of futures, and they're running sort of like parallel, but they actually switch between each other because it's not actual parallelism. It's you know, concurrency, more like concurrency. So, and this is a very cool primitive that helps you to develop things like that. It fits perfectly for asynchronous network programming, because in asynchronous network programming, right, so you have these sort of interleaved operations. When one operation is not finished, okay, you want to do another operation, right? So let's actually try to maybe apply it some way here. So echo. So since we have like accept in here, and I suppose accepting new connection is going to be future, right? It's going to future that is just like, you know, accepting connections. The problem is that, so currently we have a little bit of an inconvenience in our library, is that every time you need a new kind of future, you kind of have to create it yourself. Except if you, like, we have some primitives in here, like done and reject, right? So done always successfully returns your value, reject always throws an error, and then just combines futures together, right? If you don't combine futures together, you have to create futures from scratch. And I was thinking, can we just also create like a simple primitive that allows you to create new kind of features very quickly? Right, for example, here's the counter, and I literally have to define a structure, a method, and stuff like that. It's kind of annoying. Right, so, and the only thing I need in here, honestly, is a poll method, right? Some sort of a poll method. So I was thinking, can we just create some sort of like a poll feature? Let me demonstrate what I mean. So essentially, if I want to counter, can I just say future poll? And here I accept a function which is called when the poll method of the future is called, right? So I don't really know what exactly it's going to accept, but it's definitely going to accept the data, and it needs to accept some sort of a state addition, right? Because data is a state sort of outside of the future. It's an environment, right? So you need some sort of a state like this, and this thing will return you the same thing that the poll returns, and the poll returns you any optional, any error in here, right? So we also have to return something like this. So we're basically programming in JavaScript at this point, like accept two any's and return a single any. Right, and we probably want to like just move this entire code in here, right? Just move this entire code in here, and here is the counter, and we may actually take this counter, pass this counter through maybe state. Maybe it has to be some sort of a state. Right, so we can allocate this counter maybe in here, right, so, and it starts from 0, right, so it starts from 0, so it's 0, and we're passing a pointer to this thing. So, and this is the pointer to the state, which is going to be passed through a first argument. So in here, one of the things we probably want to do is just like use size I, and we want to cast that any to a specific type. We also want to check that its type is useSize. So recently with the chat on Twitch, we actually learned that there is a pretty cool macro in C3, which is called anyCast. Right, anyCast. It accepts the any value and the type, and it checks that the any is of that specific type, and then casts the pointer to that. Right, this is actually very useful, and it also throws an error if it isn't, right? So you can actually sort of like assert that we received the type that we expected in here, which is rather important. So I can do any cast, so I'm taking the state and I'm casting it to useSize like this, and I get a pointer to the useSize. So, and then here, so n, I also have to specify the n, but that means I have to combine I and n into a structure. So maybe I'm gonna just put 10 in here. All right, so this one becomes sort of like a 10, right, and it returns 10. Do we really want to return 10? We might actually as well return, we might return actually the state in case of a success. I think it makes a lot of sense. Yeah, just return the state. We're going to be ignoring data. I don't think we need data in here for anything. So here we obviously want to dereference this entire thing, then dereference this thing, and then dereference this thing. But apart from that, it's going to be basically the same. And if we have this sort of like a poll future, we don't really need to create our own synctive future. Right, so we can actually quickly create custom ones. Just, yeah, so this is like a new future that you want to push in here. There we go. Something like that. I'm not sure if that's a good idea generally, but I mean, it's an interesting idea nonetheless. If I try to compile this specific example, so let's do compile example. So file names must be non-empty. What? Example is invalid. So I'm not sure what the fuck are you talking about. So here is the example. And I'm trying to build, it's not compile, it's actually build, I apologize. Yeah, we don't have such poll future yet, but I think we can easily implement it. So let's actually go ahead and do that. So T3 foot, and let's go ahead and introduce a struct future poll, right? And it's going to maintain the state that we need to pass to the function. And the function itself, so the signature of that function is this one, right? So it's a peculiar signature, and I think we can define future poll fn, right? So that's what it's going to be. It's a future poll fn, and future poll fn, like this. So, and I think that's it. Do we need anything else? I don't think we need anything else. So we need to say that the structure is essentially part of the future interface. And here we're going to have future poll. What is it called? Poll, right? And a method poll accepts self and the data, right? It accepts self and the data and returns any optional. So what we have to do in here is take self, take its poll fn function and call it on self state data and just return something like that. So essentially we're just like wrapping this future interface for you. The only thing you have to provide is the poll function itself and maybe the initial state, and we're going to perpetuate the state for you automatically. You don't have to even worry about that. So, but we also need a constructor that will do that stuff for us, right? So it's this one. So I suppose it's going to be a macro. It doesn't really have to be a macro, but I mean, we can make it a macro. And in here, we're going to accept the future poll fn, which is a poll fn, and the state. So, and what we need to do, we need to return future poll. So this is going to be the state. We're going to put it in here. And poll fn. Right. And we need to actually allocate that into the dynamic memory because we'll need to cast that thing to the future. Right, so that means we're going to clone this entire stuff in here. We're cloning it into temporal memory so you can actually deallocate it super quickly, super efficiently, and stuff like that. So I think that should be enough. It's actually not that much code to add. Right, so any cast can fail. That's understandable. Right, so let's take this thing and unwrap it. Let's make it panic, and poll has to be dynamic. Understandable. Completely forgot about that. Right, so because we're overriding this thing, so it has to be dynamic. Is not a valid macro attribute. Well, I should have put it not in here, but actually here. There we go. Okay, so that seems to be working. And let's actually see if it works. Let's run the example, and okay, so it is working. So I don't really need that stinky counter, future anymore. Yeah, so I think that's much better. So with this kind of method, you don't even have to create your custom futures anymore. You can just construct them out of the poll function. Yeah, I really like that. So okay, so and we can also then this thing, right? So this is the future, and it accepts the I don't know, the result. So this is the result, and in here we can say something like, done, right? Done, and then return done, done something, right? So maybe 1 or whatever. We can also return, I think we can return null, right? So this is what we can return. So it means that specific feature is going to just count up until 10, and then it will print done at the end, right? So that way you can create like very complex futures. It doesn't really compile that easily, right? So because we have to, what do we have to do? I don't quite understand. What do you want from me? Yeah, because it doesn't fail. It doesn't actually fail, so we don't have to have this exclamation mark in here. and done is part of the foot, right? So it's a foot, and yeah, it did in fact print done at the end. So that's pretty cool. So what's funny is that if we remove that feature that prints 69 for 20 and stuff like that, right, so they're not interleaved anymore, right? So then you can disable that one, right? So that Emacs being a little bit dumb. Right, you can disable that thing, and there's only 69 for 20, and then you can run them simultaneously if you want to, right? And they're interleaved. Okay, that's much better. Like, I really like, maybe this library will be designed so you don't have to make your own futures. So we're gonna only provide like a small set of primitives that is enough for you to do asynchronous programming if you need to. I really like that. So maybe I'm gonna commit that. So let me quickly do that. So there's untracked files in here. We're gonna commit echo a little bit later, but I suppose I want to git ignore echo right away just in case. Okay, so implement poll, future poll, right? I think it's very useful. I'm gonna push that right into the repo. Hope it's gonna be successful. So yeah, it was successfully pushed. Okay, so maybe now we can use that poll feature. We can use that poll feature to actually poll the accept. That is a very cool idea, I think. I think that is a very cool idea. So where is the echo? So here is the echo. So let's go ahead. So do I even have a future? I think I have to import this thing in here, and I'm pretty sure it is going to fail, right? It's going to fail running because we don't have this method in here. So we have to update this thing in here. Yeah. And it would block and it failed with an error. So as far as I know, I think in a project you can also have sources that are global to each individual target, if I remember correctly. So if you take a look at the help, right, so list, yeah, so you can do something like HH and list project properties, right? So that's what we're interested in. List project properties, and there is just like a global sources, path the project sources for all targets, for all of them. So that means if there are some things that are shared, we can put them somewhere here, right? And here, this specific thing is shared. Let's put it in here. So, and I think that kind of simplifies some of the stuff. So I can do build echo. And if I got the comma, that's understandable. And then I can then build example. Both of them are built. Okay, so that's pretty cool. So it's sort of like shared between all of these targets. I wonder, like, I tried to look into how the target works. I thought maybe it's kind of similar to makefiles, that you can have like dependencies on target, but I don't think it's just like that. But maybe it's going to be there, right? So really kind of cool, right? So C3 comes with its own make, right? That you develop in JSON, out of all things. So anyways, so in echo, right, so we're going to be basically roly polling things. Future poll, and it's going to be a function. It's going to accept state, and I suppose as a state we're going to be actually keeping the server, right? So this thing, and suppose it's not going to finish, right? So it's going to be constantly polling the new connections, Any, so it accepts the state and the data, and we don't care about the data, but nonetheless. And the state let's actually pass the pointer to the server as the state, right? So then later, we should be able to anycast that thing to the server, right? So it's going to be anycast this stuff, actually state to the server, and we'll get the server. And this is what we're going to be doing in here, actually. This is what we're going to be doing in here. So this is the feature. So we get the client, right? We check its error, and I suppose what we're interested in, we are interested in the would block error, right? So it's going to be IO error, would block, and in this case, we don't really do anything. We just return null, indicating that the future is not finished yet, right? It is not finished yet. If it is something else, we kind of want to propagate that error, right? So, and the question is how we're going to be propagating it. We can just take this error and just like propagate it up. So it's a very funny operator, right? So, yeah, I suppose I can do something like this. Nani. So, but if it was successful, right, if it was successful, we may want to create a new client. Maybe we want to even construct a new future in here. This one is going to be rather interesting. So, what I recently came up with on the stream is a very interesting technique, is like basically of having two lists of clients instead of a single hash map, because the most logical thing would be to have like a hash map that sort of like maps the TCP socket, maybe even like a pointer to this TCP socket, to the socket state of some sort, right? So some sort of a state, and the state of the TCP connection is going to be what? Like the socket itself, right? So that's the thing, and also maybe it's internal buffer, right? Because as you can see, we allocating a buffer per client. So this is something that is kind of useful. So instead of having this hash map, right? So, and just inserting new client into that hash map, and when the client dies, removing it. So I came up with a basically technique of two lists, right? So we want to have like a client structure, which is going to contain the TCP socket. And right, so this is the socket. Well, let's call it sock for the consistency, because in the standard library in all of the places it's called sock, like in here, for instance. And let's also allocate like a local buffer, and 24. So this is going to be the buffer, right? And we're going to have a list of these clients, and this is the clients, right? And on top of that, on top of having the sock, we also need to have the future that is processing the logic of the client, right? So the future is going to contain this logic, actually this logic, maybe even the entirety of this logic, right? So the future is going to do these kind of things, right? The future is going to do these kind of things. And right, so this future is going to be allocated here. So it's going to be future, foot, maybe just future. So essentially, we keep these clients, and we're going to be iterating through all of the clients and polling its future, right? We're going to be polling its future. So let me do the following thing. So I'm going to do for each client in clients. Maybe we're going to be iterating them by a pointer, right? And for each client, we take its future and we polling it, right? So we're polling that specific thing. And I suppose as a state, we may actually pass ourselves as like the client as the thing, because I think the client will need the socket, the buffer, and so on and so forth, right? So this is what we're going to be passing in there. So we're providing the client, and since it's a pointer, we can actually do something like this, right? And this thing may either fail or succeed or finish, and so on and so forth, right? So here we probably want to do the following thing: if maybe catch an error, right? So you catched an error. And depending on the error, I'm not sure what exactly are we doing. We're going to be probably maybe throwing that error somewhere, or maybe just ignoring. So I suppose we can say that if an error has happened, we have to finish the future. So if we're using the hash map, we would have removed that client from the hash map. What we're going to have instead is we're going to have clients next, or maybe clients new. It doesn't really matter. Maybe let's call it clients next. Right, so where you either push the clients or not, right? So for example, if it failed, you don't push the clients in there. The thing you do, you just close the connection, or you just close the socket. But maybe we can allow the sockets themselves to close the connection. It's going to be rather interesting. But yeah, so you basically close the connection. And if it succeeded, right, if everything is fine, so this one has to be catch to indicate an error. We just add clients next. We just add that client to the client next. That's what we're doing, right? So we either add it to the second list or not add it. And then what we do, we just swap them. So we swap clients and clients next. That's it. So, right. Because I'm going to be iterating them linearly anyway. And as I'm iterating, I'm going to be making decision either to, remove the client from our list or to keep it. Might as well just have two lists in here. Right, and obviously I probably need to also clean, so clean the initial list so it becomes empty, and I just swap them around and I repeat the process, and it's just like the round robin and stuff like that. And we don't need a hash map, right? So because we don't really do any insertion and removal operations, we do them as we iterate the things. Might as well just construct new list, right? It just like makes it easier, in my opinion, right? So usually in this kind of situations I used hash maps, but I think for this kind of stuff it's not needed. Maybe if you make the logic of handling the clients more complicated, at some point you will have to switch to hash maps, but this is a simple echo server example, right? I don't think we need anything super complicated in here. In fact, if we can get away without hash maps, I think it's a good idea, honestly. I think it's a good idea. Right, and essentially, as we get the client, we need to insert it into this client's list, so then it can be processed later in here. Right, so let's actually go ahead and do that. So the client push, and we want to push a client. So in a struct client, we have these kind of things, right? So this is the socket, right? So this is the client. Or maybe I'm going to call it sock. Right, so this is a sock, and this is the sock. So then this is the future, and this is where we want to construct the future. Right, this is where we want to construct the future, but I'm not going to do it right now. And also buffer, but we can just zero initialize this entire thing. Right, so we insert in this entire stuff, say client connected, and just move on. This entire thing kind of just creates a future, but you also need to poll it from time to time. Right, so what I'm thinking is that we need to actually create this entire stuff outside of the loop, because it's the loop that is going to do all of that stuff. And here is another interesting thing, right? So now to push a thing into the client's list, right? To push a thing into a client's list, we have to know its pointer, right? So that means as a state, we have to we have to pass it there. So maybe we're gonna have another structure in here, which is called server, right? So let's go ahead and do that. So it's gonna be server, which is going to hold a TCP server socket, right? So this is gonna be sock. And right, it's going to also store the pointer to the clients, right? So it's gonna be clients and the pointer to clients. There we go. So that way, we can construct the server like this, right? So this is going to be server. So the socket is server, right? So I would like to call it sock as well to make it consistent, but then I think it's going to interfere with some of this stuff, but maybe not. Maybe it doesn't really matter that much, right? So let's actually call it, let's keep it as a server, and because of that, this one is going to be client. Yeah. I don't know. Naming is hard, okay? Naming is hard. And the clients is a pointer, right? So this is the clients, and we take a pointer to the clients, and there we go, here is the server. To make it actually kind of consistent, we can keep the accept future inside of the server as well. So future. All right, that's kind of cool. So that means now I can do future, and I can just put this thing in here. Right, I can just put this thing in here, and then, if I want to poll it, what I do, I take the server. So the server is constructed like this. I take a server, I take its future, and I just poll it with itself, which is kind of similar to how we do that for clients, right? So we're starting to actually kind of see patterns in here. I can't put R in here for some reason. Okay, we're starting to see patterns, right? So here's the server future, and we put the server, and here is the client, right? Client future, and we're pulling client. It's kind of cool, right? So it's kind of cool that we're starting to see the patterns. So the future accept future is never gonna fail, right? So that means we can actually unwrap its failures, but the client future may fail or may not. Actually, I'm thinking that maybe we can implement it so it doesn't fail, and when it needs to exit, it is going to simply finish itself, right? So maybe in that case we can, so if it catches an error, we shouldn't propagate it. We can just log it within the future and just resolve the future. That way we either succeed or not. So here we can essentially unwrap it, and if this thing is successful, that means it's finished, right? And we basically close the connection and don't add it to the list. But if it's not finished, if it's null, we just push it to the next list, and then we clean everything up, and then we swap it, right? So that's kind of cool. That's kind of cool, right? So, and the only thing we don't do in here is that for the client, we don't set the future. I haven't actually compiled my code for quite some time. Just like I'm in a flow. I'm just like putting down my my thoughts, and I just realized I haven't compiled my program. Maybe whatever I'm doing is like never compiles, and maybe it's a complete fucking bullshit. Let's actually pause for a moment, because my brain is currently exploding with different ideas. Probably because I don't have a chat, Twitch chat, that is constantly distracting me and knocking me out of the flow state. Right, anyway, so let's actually try to compile this entire thing and see if this is not complete bullshit. So far, we have only semicolon problem. Right, so, and expected something as 43. What do you want in here? So here is the poll. Oh, it's, I mean, it's comma, you want comma. All right, so we don't have a list, which is understandable. So it's suggested to have collections, right? So let's import this in Emacs. Let's import this entire thing like so. Let's fucking go. So server would shadow a previous declaration. Okay. Who would have thought that the most difficult problem here is like how to call these things? So let's actually call it server sock, right? And this one becomes server sock, and because of that, the client one becomes client sock, right? So I think it's fair to call it a client sock, right? So far, nothing critical, just like a minor compilation errors could not be found. So this is also very minor. So it's basically a server sock. Well, I mean, it's a server sock. Too many layers of wrapping of sockets, right? Too many layers of abstractions, man. Anycast, right, so that's understandable. Anycast must be unwrapped or handled somehow, or maybe we can propagate it, but I mean, it's better to actually, you know, break it, because it's more of a, like an assertion. So implicitly casting to the pointer, right, so it doesn't... Client sock accept... it's already pointer. All right. What else do we have in here? Client could not be found, 33. So we are doing what? It's a client sock, right? So because this call returns either error or something else, right? So we need to indicate that, and we need to unwrap it, and we need to handle it. So far, all of the errors is just naming, right? So I fucked up some of the naming. Clients, it's part of the server. Oh, this one is interesting. Since I'm now passing the server basically itself in here, this entire thing has to be actually server, server. And because of that, when I'm accepting the server, it's actually server sock, right? It's a server sock, but it's actually value, which means that I have to take it by the pointer. Right. So I'm copying it by that. So this is by the pointer, and when I do server, and let's go to the next compilation errors. What else do we have? There's no server sock. Understandable. All right, this is the client sock now. This is the client sock. Right, so what's the next one? This is not a valid member 28. It's a server sock. I think I'm... Yeah, let's call them servers. The most difficult problem here is how to call the goddamn fucking socket. And the reason why I have this problem in the first place is because learner wrapped too many sockets. Right? Why did you create so many freaking wrappers around this such a simple abstraction as the socket? But now I have to deal with like how do I call different layers of different socket wrappers? Because look at okay, I'm gonna show you what the fuck is the problem. Right? You have a client, it has an internal TCP socket. Right, it has an internal TCP socket, but then you can take a look at the internal definition of TCP socket. It's a socket, okay, but within the socket definition, if you take a look at the socket, it's also a native socket. Like the underlying network, like operating system abstraction is so down fucking below that like I need to now to come up with different names for different layers of abstractions of the fucking sockets. And I need all of them, right? So it's annoying. It's freaking annoying. Like, it's just like, I mean, yeah, you can solve any problem by piling more abstractions on top, but except too many layers of abstraction, right? So, and now we're starting to have this kind of shit. But anyway, 39, right, so this thing, something may fail. Result of this call is optional due to its arguments. Who is optional? Who the fuck is optional? It can't be optional. So you're telling me that this thing is an optional, right? But then I did a catch, so that means it unwrapped it. And are you telling me that push is an I don't think push of the list is optional, is it? I think something is fishy going on in here. So C3 std collections list push is not optional. You telling me that this thing is an optional? Did we just found a bug in the compiler? Yeah, we found a bug in compiler, I think. Maybe. But you never know. Right. So the thing about if catch, if you have an optional value in here and you did if catch, it's supposed to automatically cast it to a non-error, but it didn't do it in this specific case. It just didn't do it in this specific case, unfortunately. Probably because, I don't really know why, but I mean, one of the things we can do in here is just maybe put it in else. Right. Yeah. I think it's a bug of the compiler. These two code is equivalent, but the analyzer of C3 couldn't actually figure that out for some reason, maybe because there is an additional layer of switch cases in here. I think we found the compiler bug. So yeah, we found this is a compiler bug. Anyways, so let me actually try to do the rest of the things. At least there is a workaround in here. At least there is a workaround. So here's the client future, and we have to pass the client in here, and it doesn't like, I cannot convert pointer to any, try passing the address instead. I thought if I do something like this, it's going to be a pointer automatically. Do I have to do some shit like, no, I can't believe that. Right, so do you have to do something like this? No, I explicitly said that please make it a pointer, and you didn't make it a pointer. That is annoying, honestly. That is really, really annoying. And now I don't believe it. Is it actually returning a pointer to me, or it is not returning a pointer? I don't know. You can only convert pointers to any. C3 lang. So let's take a look at the examples in here. So for each, enabling for each. Oh, this is not what I was looking for. How to use for each. For each element by reference. Yeah, this is what I'm talking about. Ah, you have to put a reference in here. Okay, I see. Okay, that makes sense. Okay, socket is no method because it's a sock client, right? So sock client, and maybe since the fan of my laptop started to work really, really hard, probably because of C3 website, I don't really know what exactly happened. But anyway, so here, if we don't want to make the future fail, right, so if it succeeded, we just close the socket, but we might as well actually close it in the future itself as well. Meaning that maybe we're going to do something like this, right, and to invert the whole thing, we can do something like that. Right, if it's not finished, we keep pushing it into the next. If it's finished, it is finished. Right, that's about it. Okay, makes sense to me. So that simplifies the whole thing even further. Right, and now I think this is going to compile. No, it's not going to compile. So you cannot cast type pointer client. Yep. So we have to push it by value. All right. Okay. So, and I suppose this one is clear. Missing return statement in the function, but which one? So which one returns something? So this is poll, and I suppose this has to be... Okay, so as we poll in, we always return null, right? We always return null. So socket accept, well, I mean, we have to probably return null in here. Client connected, and we just continue. All right, so where do we have to return? So here's the function that returns void. We don't have to return void. So here it will always fail. So I suppose one of the things we probably want to move it in here. Something is wrong with the control flow analysis of C3. For some reason, it just can't figure out that this branch will never exit out of the function. Because look at that. So you go here, it then will go into either would block, which goes out of the function, or will default with this thing, which will also go out of the function. All right, it's just basically panics. Not really goes out of the function, but it just like, you know, crashes. So the function, if it goes here, yeah, so there's something weird. The control flow analysis somewhere here is kind of broken, right? So maybe I will have to we'll have to create a, like a, you know, pull request or maybe issue for C3. It's like I can feel that there's something wrong, right? Maybe I can even find it, but it's kind of outside of the scope of today's stream. Anyways, right. So everything seems to be working. So the only thing that we need to do in here is to create a future for the client, right? So we have a future for the server that accepts things, and now we have a future for the client that does the client logic, and the client logic is going to be basically this, right? So it's going to be basically this. All right, so what we have to do, we have to read some data from this socket, from the socket. We might as well actually also employ poll. In this specific case, we can do foot poll, right? And this is going to be our thing in here. So it's a foot poll, and the poll, right? What is it going to do? What is it going to do? For its state, I would like to maybe have the pointer to the client itself, right? I would love to have a pointer to the client itself, but I'm not sure how easy it is to do that. And I think, yeah, since we poll in the client, we already give it the pointer to itself, so the state is already going to be client. So it's actually kind of cool, right? So we can do client, and then any cast state to client, right? Like this. So within the client, we have a buffer, right? So if we take a look at the definition of this client, yes, it is a buffer. Client buffer. But it's actually not the state per se, it's the data that we pull it in here. That one is interesting, honestly. Right, so it's kind of difficult to tell. Right, so because there's like two of them now. I think I need to make a small break. I need to make a cup of tea, and after the break we're gonna figure out what's up with that. So because I have a state, right, of the future that is stored within the future, and the data, sort of like a data environment data that is sort of passed through the poll, and I'm honestly not sure if that's a duplication of the functionality, right? So because you might as well store the state always in that data, you can just always store it there, and effectively, right, in this thing only accept the state, and it basically becomes the same as the poll method of the future, right? And just keeps all of the state in there. But then I think it will break this example with a counter. Will it break this example with a counter? Not really, actually. It may. It may, if you have like a combination of the futures. If you have futures that run simultaneously and you have a future that is facilitating running simultaneously, each future may have its own separate state, but all of them receive the same environment. Yeah, and because of that, I feel like this data should have been actually called environment, right? So to sort of distinguish them. So the future has its own state, but it also has its own environment, right? and you can have a future combinator which runs futures simultaneously. Each future has its separate different state, but they all receive the same environment. Right, so I think without any break, I already kind of figured out how exactly I want to approach this entire stuff. Right, so, and actually, I want to query replace all of the data with environment, right? So when you poll the future, you don't really receive the data, you receive environment that is outside of the state of the future, right? It's kind of important, I think. So to keep that in mind, to separate that at least mentally. And then you have a state, right? And usually with the custom futures, that state is stored within the structure, right? But with the future poll, which allows you to quickly construct new things, the state is stored in here. And that additional poll, it accepts both this state and the environment. And when you're designing the future, you need to make a conscious decision what is considered state and what is considered data. So, or considered environment, I would even say, right? So this is environment. So where is the data? So this also environment, right? And in the counter example, the example that counts, not counter example. So yeah, I think, where is the example? This one. Yeah, we call it environment, and doesn't even use that because we ignore the environment, right? So this is a state. Right, and in the echo, we need to make a very much conscious decision. What is the state? In case of a server, I think the point of the server itself is the state. But in case of a client is constantly moved around. Because between two lists and stuff like that, and we don't really know what is a state. We don't really know, and because of that, maybe it has to be an environment. Right, it's kind of a stupid thing, but with this specific setup, this state of the client is actually part of the environment because the clients can move around a lot. And that's probably where you want to use hash maps, so the clients don't fucking move too much. But I mean, they still can move around because they are within the hash map. Right, so a hash map may resize and rehash at any point, so they're also moving around. Right, the borrow checker would have solved that, am I right? Am I right, Rust fellows? Yeah, I guess in case of a server, we store the server in the state, but then, right, we use the environment in here. But maybe for the sake of consistency, we can make a conscious decision to do env. But in that case, I should not provide this thing. Right, makes sense, because here we provide the server, and here we provide the client. So, and by the way, why did I do reference in here? Oh yeah, because it's a value. It's not a poll. Yes, so we can make it an environment. And by the way, I think poll should have a default argument. Yeah, finally. No lol. No lol. Right, so essentially, if you don't have a state, you might as well just not accept it. Because why not? Why do you have to accept it? Looking good, looking good. I didn't even need a break. Didn't need a break. That's very, very cool. So I think I unblocked myself just by arguing through, just by prompting myself, essentially. Anyways, so here's the client. It has a buffer, right? So which we probably want to read. So how we're going to be reading this entire thing? So we're going to do, you know, client sock, and we can just read this thing. And obviously it may fail or return successfully. So we can try to catch the error in here. So we're trying to catch an error. Well, we probably don't need to do any, so let's actually call error. One of the errors that read may return, if it would block, is would block, right? So IO error would block. And in case of would block, we just have to try again later. So we just return null. So the future is basically the poll was not particularly successful. We need to wait a little bit. If it is something else though, right? If it is something else, we will throw it up, right? We will rethrow it. So that means it's something unexpected. So that will automatically fail the feature, and it will fail, basically panic in here, right? It will panic in here. So after that, if n was 0, that means the client probably closed the connection. So in that case, we can actually return maybe self, or we can return environment, right? The environment itself, right? We just need to return something that is not null. Environment is definitely not null, so let's just return that thing. Otherwise, right, otherwise, I'm actually not sure. We can do a very cool thing. What if we, okay, so what if we allow this entire thing to fail, right? If it's n is equal to 0, we might as well actually not even fail, but yeah, let's fail. Like connection closed, right? Say client error closed, like this. All right. So if we return 0, the client connection is closed. So that means I can do things like catch. Look at that. I can now catch. Right, so, and depending on what I caught in there, right, so where is my catch thingy? Right, so I can do different things. I can recover from that. So, and in here we actually accept the any case, which is the excuse, which is the error, right. And here I can check that that specific excuse is closed, and in that specific case, I may, you know, recover based on that. So I think that's fair. I think that's fair. So, and in here, if we successfully did something, right? If I successfully did something, we have to return a successful result. How are we going to be returning a successful result? We can just do maybe, yeah, let's just return an environment itself. The point, like, yeah, so itself, we return itself. Not even sure. Man, like the logical thing here would be to maybe return a buffer of this specific size, right? Of this specific size. But then where the buffer is located? So that's the real question. Where the buffer is located? So we are allocating this as a hard array. And because we're moving things around, constantly moving things around, the buffer itself is also going to be moving around, which is a pain in the ass. So what I'm thinking is that we have to do is maybe keep it as a slice, right? Basically keep it as a slice. So then when we are constructing the client, right? So when constructing the client, we can basically allocate this thing. So we can do buffer mem new array. I think it's just like a new array where we have to specify the character and the size of the array. So it is a slice, right? So we know that it is a slice. So just because the slice itself that contains the pointer and the counter moving around doesn't mean that the pointer where it points to is going to be moving around anyway. So it becomes a stable memory. So because of that, here I'm just constructing a new slice and I'm just returning it in here, right? I'm simply returning it in here. And that should be fine, actually. Yeah, so the downside of this double list approach, is that clients are not fixed in memory. But it's not a double list approach, as I already said. Hash map would have had the same problem, right? So the hash map would have had the same problem. So here we have to return the successful value. Successful value has to be any. I can try to take a pointer of this thing, but it's pointed to a slice that is located on the stack, right? So because you have to understand that the buffer itself that is allocated in dynamic memory is in one place in the memory. The slice that points to that buffer is in a different place in the memory. By taking a pointer like this, I'm actually taking a pointer to this slice that then points to the buffer, right? So, but I need to return this slice as the final thing that it can work with somehow. So because of that, I feel like I can just use, I can just clone it, maybe in a temporary memory. Just clone it like that. So yeah, maybe even like this. So when I do a clone, it's a slice, it's going to clone that slice, and that slice is going to be just somewhere in the temporary memory. And we can do then, right, and in here, we have a very interesting thing. Right, so it's constructing a new future. The future constructor accepts the result, which is going to be the pointer to that specific buffer. Right, that's what it's going to be. Okay. So, and in here, right, if everything was successful, we have to write that value into the client. Right, we have to write that value into the client. This one is going to be rather interesting. All right, so I think I still need to make a small break, right? I'm going to make a cup of tea, and after the break, we're going to finish this entire thing. So my idea is that I want to have a future that reads things, then passes stuff to the future that writes things, right, and the write future just basically terminates. So then we'll need to introduce another future combinator, which is just runs them forever, right? So it will need to turn it into a loop. So essentially, we need somehow encode this entire logic asynchronously, if you know what I mean. We need to encode it asynchronously. Right, so each of these operations is going to be asynchronous, and we also need a synchronous version of like a while true, which goes forever, right? And it's going to be a combinator that basically recreates the same future over and over again. I already done it before. It's really unclear how to do memory management in this specific setting, but I think we'll figure it out. All right, let's make some break, and all right, I'm back. So let's actually continue. I was thinking that I think one of the stuff I want to do is probably change what is going to be considered the state for the client and what's going to be considered the environment for the client. So I think the state for the client is going to be the buffer specifically, but also maybe not only the buffer, but how much was read, right? So we need to keep track of both buffer and n. Right, that's what we need in here, which is kind of annoying to work with, right? So, but I think we can figure it out. So in case of this server, I think we can just keep everything as an environment. I think that's totally fine. Right, so it turns into this really interesting game of like deciding what's for the future is going to be the state, right, and what's going to be the environment. And they kind of have different lifetimes. Right, so the state has to persist for the entirety of the existence of the future. An environment can, you know, may exist only for one single pole. Right, so environment is a thing that exists for one single pole, and a state that exists for the entirety of the whole thing. By the way, so the main problem that I had in here is that the client is not really fixed in memory. It's constantly moving around. Who said I can't just like have pointers in here? Right, so why exactly do I have to actually store them by values? Right, I can just have pointers and then can go back to. I mean, yeah, like why didn't I fucking do that? It's just like, and the client itself may become a future then, but I mean, whatever. So that's kind of cool, right? So just like make them pointers and just allocate all of that shit on the, you know, in a dynamic memory. Why not? I think that could be a thing. So let me see how we can even do all of that. So in terms of a future, it's not going to be particularly convenient to work with this entire thing, but maybe no. What if we just clone the whole thing? All right, so we're going to be cloning this entire thing, right? And then I'm going to push it in here. So essentially, what we will have to do is then not on like when it's finished, we just free that thing. So in here we can actually do it like that, right? So we pass it like this, and then when we push it, we don't have to do it like that. And then yeah, but I think that's much better, right? So in that way, yeah, I definitely needed that break. Right? So once you get stuck, right? So the best thing you can do is actually take a break. I'm telling you, bro. I'm telling you. So, and in here, we're just returning the client. So that actually makes everything easier, I think. I definitely think that it makes everything easier. So if it's 0, we say that it got closed, right? And in here, So essentially, what we have to do, we have to probably assign that end to the client and pass that end to here, right? So, and then after that, we have the result, and the result is basically the client state, or it's more like an environment. But anyway, so we can now take this thing, right? We can take this thing and simply construct another future, right? We can construct another future out of that by returning sort of another pole, if that makes any sense, right? So we create another pole. Well, honestly, in that case, we don't even need the result then. I don't think we even need the result in that case. So I feel like I'm programming in JavaScript, actually. It does feel like I'm programming in JavaScript. So this is that pole, and in here, we're also going to be taking the client as an environment, right? So because we're just like doing it like this, right? So we're constantly adding client as the environment. And in here, since the client itself contains the buffer and n, we can try to asynchronously write something in there, right? So, but we have to do that sort of in a loop. Right, so let me see. This one is going to be rather interesting because here we reading only once. We're reading one chunk that we managed to read, but when we're writing back, we need to make sure that we wrote everything back, right? So we need to make sure that means we need kind of 2 pointers, right? So essentially, if client I, so the how much we already written, is greater or equal than the client n, that's already kind of over, right? So we can just return the state itself, right? Or the client itself, right? So it's over, it's done. Right, if now we have to try to write whatever we managed to write in here. So how are we going to be doing? So we take a write, we take a buffer, we have to take a value starting from the client I up until client n, or I'm not quite sure. We might as well actually use it as the length as well, right? So it could be I and n, right? And then if this thing has failed, right? So what's going to be the error in here? So it's going to be n. If we got would block, right? If we got would block, we just return null. That means it's not finished. If we got something else, that's an unexpected situation. That is straight up unexpected situation. If n equal to 0, that means I suppose the connection was closed. I'm pretty sure it was closed. So if we get something else, what we have to do, we have to take client I, advance it by how much we've written, and also n, subtract how much we've written, and then we just return null, but only if we went over this entire thing. Well, I mean, this is not correct. So n actually denotes how much we've written in there. So that means what we have to do is to just check whether it's equal to 0, right? If it's equal to 0, we instantly return the client, indicating that everything's fine. If after that it's equal to 0, we instantly return client. Otherwise, it's not finished, so we just return null. Okay, so that's pretty cool. So we have two sort of futures in here. We may actually try to factor them out to separate function. That would have been actually kind of cool. Right. So, and then this entire thing may fail, right? So that means we need to catch, right? So we're going to do fn, so catch. So where's the catch function? It returns future or any fault accepts. So this is the error, like this. So, and we need to check that this specific error is closed, right? So that's what we need to check. If switch, maybe we can even do something like this. If error is equal to client error close, we return done. We just say, okay, everything is fine. Right. If it is not, we have to reject it, right? So it's going to be a reject. So we're sort of propagating it back. So that's kind of the whole point of this thing. So, and that's basically the logic in here. So this is responsible for a single read, this is responsible single write, and this is responsible for sort of like getting out of the loop, but we don't even have the loop in here. So a loop would be a forever future that constantly constructs a new future in here. So let's actually try to maybe compile this entire stuff just to see if it's going to work or not. Right, so it doesn't like 43 poll. Let's actually see what's going to be the next. 70, all of that is just syntactical stuff. 85 is going to be that. Right, so yeah, 41 new array. We don't really have to do that stuff anymore, right? So because we're just like allocating it on a heap, right? So constructing this structure and simply allocating all of that on a heap. Nothing particularly special. Right, so what do we have? We don't have a client error. Let's introduce that. So it's going to be fault, client error, and this one is basically closed. Right, so the connection is closed. What else doesn't like? 61 B N. Why is it B? Okay, so that just worked. That just worked. But I mean, that is going to automatically close the connection, right? So, and furthermore, by the way, since we're going to be closing the connection, do we even have? Yeah, we don't have an access to that thing, unfortunately. So we don't have an access to the client state or anything like that. So probably what we have to do, we have to close the socket ourselves. Yeah, I was thinking that maybe we didn't have to do that, but we do have to do that. So just close this entire thing like so. So client connected, and then we also maybe want to print something like client disconnected. In this specific case, funnily enough, yeah, it's kind of similar in asynchronous code. So in case of a success though, right, we just do it like this, client disconnected. That's the entirety of the code. That's the entirety of the future. We can test it right now. I think we should be able to test it right now. So it's not going to repeat. It's going to only like do the message once. But I think if it works out, it's going to be actually super cool. Right, it's going to just like constantly wait for this stuff. And yeah, let's fucking go. Hope it's not going to kill my entire system. All right, let's do run. And might as well take a look at this thing. So is it consuming all of the memory? Don't really see. Where's the memory consumption though? I don't see the memory consumption. I don't see. Oh yeah, here it is. So the memory is not growing. I was maybe worried that maybe the memory is going to grow. But anyways, so yeah, and the usage as actually of the CPU utilization is actually super high because we're basically spinning on these things, right? And you have to do that a little bit differently, right? So you're not supposed to block by spinning around. You're supposed to use things like poll and ypoll, right? So, and we're probably going to use them at some point, right? So, but because we're doing an example in here, I don't want to overcomplicate the example, but like spinning like that all the time is not a good idea. Just saying, right? So you're supposed to use some special operating system mechanism that allow you to just listen for the sockets, and if there's no new events on the sockets, just basically sleep, right? Don't spin on the CPU. Okay, so let's do telnet localhost. Let me open the log. Localhost 6969, and if I do hello, it printed hello back, and it instantly closed the connection. What's funny is that now I'm pretty sure I can have two connections opened up. Localhost 6969. Right, I can do tests. So something is wrong in here. I think I even know what. So we forgot to mark the client socket that we received in here as non-blocking as well, right? Just because we mark the server socket non-blocking, it doesn't mean the client one is non-blocking. So we have to do client sock set non-blocking true, and that is also going to work as well. So the code is a little bit scary right now, but this is because I didn't work on simplifying it, right? So I'm just like trying to lay it out, right, to make it work, right, and then we can actually work on making it better. All right, so let's give it a try. And something wrong, accept failed, accept was unwrapped. Fascinating. So it didn't allow me to set this thing as non-blocking. Why? Because I'm a dummy dum-dum, right? I should actually do that when I'm confident that it is, you know, was unwrapped properly, right? I put it in a different place, in the wrong place. Okay, so now if I do a connection, right, so I can then maintain a different connection, then I can do hello here, it returns hello here, it returns hello here. So what's funny is that it's kind of difficult to see that they are in fact interactive and everything, right? But these two connections don't consume 2 threads at all. Let me show you. So I think it's echo, right, there we go. So there's only one process in here. It's all done in a single thread. So that was cool about it. And by the way, here is the course spinning on that loop, right? So you can actually, I think one way to fix that is to basically put a little bit of actual sleep in here, but then you are not that responsive anymore. So you're gonna have a lag of that little sleep. Right, the proper thing to do here is to use this sort of syscall, this mechanism. Wait for file descriptors. You provide the array of file descriptors, and I suppose it sleeps until one of them, just like data on one of them is arrived. Since we already have a kind of like a list of file descriptors, we have a list of clients, and within them we have sockets, and within the sockets we probably have file descriptors, right? So we have to dig it out of the abstractions of these 3. We can just put them into like continuous array and pass it to poll, and it will probably sleep until one of them just wake up. And then we can poll that specific, you know, future associated with that specific file descriptor. Or maybe we can just poll all of them, right? So just like if one of them woken up, we can just like poll all of them and then go to sleep once again. Kind of an interesting idea. But again, I don't want to overcomplicate things. So as you can see, it only reads once. We need to actually do that forever, right? So usually for this kind of stuff, I create a future, which is called forever. Does it spin? My fan is actually still working, but I suppose it's just like trying to warm up, to cool down after spinning. So the thing we want to do in here, we want to introduce a new kind of future. So let's go ahead and do that. So we already have a poll future, and we're going to have a future forever. So it's a future that accepts a future, right? So let's create a macro that constructs that. So future, and it actually doesn't accept a future. It should accept a function that constructs the future, right? So let's put it this way. So this is going to be future forever fn, right? And it returns a future, but does it accept anything? It may accept something, but maybe it can accept an environment, or maybe some sort of a state, or something, right, that is useful during the construction, right? So I'm not sure if it's an environment, but it's more like a data that is useful for construction. Kind of hard to tell, but anyway. So here's the function, and here we're going to have a forever fn, right? So which is this specific function, and then the internal future, right? So the forever future. And also the data that might be used during construction of that future might as well maybe just called arguments, right? Because you never know, right? There's no closures in here, so it's kind of difficult. Maybe call it future, right? So, and let's go ahead and implement the interface. So let me find the poll, right? That's the interface. So it's going to be fn any future forever poll that thing. There we go. So here's the thing. We take itself and we take a look at the future, right? A future is initially going to be null. If it is null, we have to first construct it, right? We have to construct it. How are we going to be constructing it? We're going to call the forever function, right? And we're going to supply the argument that we have in here. So it's that argument. And that way we constructed this entire thing. So after we constructed this entire thing, we need to poll it, right? So it's going to be poll. And we provide the environment that is passed through the poll. So this thing may fail, so we're going to propagate that failure. So that means if you want to get out of the forever future, you just have to throw an error there somewhere. So, and if it finished, right, if it finished, we do not return that value, actually. We set the future to null, effectively leaking a little bit of a memory, because in forever fn, we probably allocate a lot of memory, at least in a temporary allocator, because we use t-clones in here. So that leaks a little bit of a memory. But let's just put it aside, right? So to do leaking memory, right? So after that, I always return null, indicating that the future is not finished. So on the next poll, that future is going to be created again. So that way, you can create like a perpetual process. You have a thing that does it once, you wrap it in forever future, and it does it indefinitely, constantly repeating it. So it's infinite loop, effectively. It is an infinite loop. And here is an interesting thing. So we allocate all of the memory usually in a temporary allocator, but what if we allocate it with a heap allocator? So let me actually do the following thing. I'm going to do t-clone, and I'm going to replace it with clone. By using just clone, we're allocating everything in the heap, right? Which makes it difficult to clean it up arena style. But recently, I found a very cool thing in C3. I found a macro called scoped. Let's actually find it. Scoped. So here it is. It's a very cool macro. So what it does, it accepts an allocator, whatever allocator, right? It also accepts the body. So it's a macro with a body. So it takes the thread allocator, which is the default heap allocator. It is the default heap allocator. It saves it. Then it replaces that heap allocator with your allocator, right? And then runs your body. And then at the end of the scope, it puts back the old allocator. So you can basically mark a region and say, within that region, use that allocator. Think about it. So we can have a custom allocator within the future forever, right? So within the future forever, some sort of allocator. Right, and we can say, okay, for the entirety of this entire thing, right, so scoped, use that allocator, and when it's time to recreate the future again, let's take that allocator and reset it. So, and since I put it in scope like that, even the poll, so the inner future of the forever future is also going to use that allocator. Right, and we can even use arenas. As far as I know, in C3, we do have arenas. So it's somewhere in memory, it's a core allocators. Then, yeah, here's dynamic arena. And it's a classical arena that I implemented in the past in C, right? So it's basically a linked list of dynamic pages, dynamic arena pages on a single page. Wonder, yeah, so here's the page. Yeah, so it's a, it isn't, oh, so it's a previous arena. It actually stores them as a void star, so kind of weird linked list, but anyway. So we can try to maybe get this arena allocator, right? So we can try to get this arena allocator and maybe put it somewhere here. And I feel like you have to initialize it. Do you have to initialize it all the time? Well, I mean, we have a constructor of this entire thing, so we can initialize it somewhere there, right? So let's call it arena. I think it's kind of cool to call it arena. So this is arena, and this is arena, and there we go. So yeah, I think I should use arenas more for this library, right? It will make the memory management much easier. So, but the thing is that when forever future is done, we have to distract that thing. We have to distract the dynamic arena. So there should be something like destroy, or maybe it's part of the, So acquire, alloc, reset. Here's the reset, which allows you to reset the arena, which is nice. Release, try it out. It's a really specific pointer. I don't see how you do that. So free, oh, there is a free function, and it just, okay, it just frees the entire arena. Okay, that's cool, that's cool, cool. So this is something that we can do as well for the forever future. Maybe future should have some sort of like a free method, right? Just freeze everything. Anyways, so let's create a constructor for this entire thing. So it's going to be a macro that returns a future forever, and it's going to accept future forever fn, and arguments, right? So which is any arg, and it's going to be initially null. Right. So, and in here we just constructing the forever future. So did I call it correctly? Future forever. Ah, okay. All right, so future forever. Right, so I need to construct it in some interesting way. Yeah, so for let's call it future. So, and what are the parameters that we have in here? We have an argument, we have some other choice. Okay, so here's your arguments. Let's go. Then forever fn. Future, the internal future, it should be initialized with a null. Arena, let's keep arena essentially empty. I don't really understand why you need to initialize it, but whatever. So, and then we do future arena. So let's not keep it arena init. And I think arena init has page size. You have to provide the page size. So let's maybe allocate kilobytes, maybe 20 kilobytes or something. So something like that. Does it throw errors? It doesn't throw errors. Honestly, I don't understand why you have to allocate it. It's just like zero initialized should be a valid state of any object, in my opinion. But anyway, so then we're gonna clone this entire thing. And by the way, clone uses the current allocator, so that means I can even nest futures, and each forever future, I mean nest forever futures, and each forever future has its own arena, and they're gonna, oh, that's actually kind of cool. All right, so that's something. Yeah. Okay, so here's the forever stuff. Let's try to recompile the whole thing and see if it's going to work. Right, so here's the echo. Semicolons, right. Anyway, I'm sorry. So there's a running joke recently is that the most difficult thing in programming is finding missing semicolon. Especially consider that the compilers, modern compilers, tell you where exactly it's located. So scoped, is it part of the like a mem scoped? I think that's what it is. Self arena convert pointer to allocator interface. Really? So do you have to take it as a pointer? Maybe I have to take it as a pointer. Look at that, bruvskis. Look at that. Okay. So let's go to echo C3, and so here is the future for the client, right? That's what we have, a future for the client. What we have to do the forever future. So forever, and we have to create a function that returns a future and accepts arg. Right, and this thing, we can just like literally return it like that. So that's basically what we have. Right, and kind of difficult for me to understand, to orient myself properly. So we just return it like that. So that means here we have to put a semicolon. Just a second. All right. So here is that, and then I have to close this thing now. Yeah, I fucked up somewhere. I need a full screen. Okay, so finally I have a full screen. Okay, so this is that. So that's cool. So that means here I have to close it like that, and that should be fine. All right. Cool. So here's the forever future, which is going to keep calling that. So do you have any T clones in here? I didn't think so. So every time I do this kind of stuff, I actually locate it in here. funnily enough, wait a second. Chat. So when we do, where do we allocate the client? We allocate, yeah, we allocate the client actually down there. So it's not allocated accidentally within that. What is it called? Oh, it is allocated. Right, it's allocated within the future, but it's not going to be allocated within the arena of the forever, because forever is somewhere there. Okay, so that's fine. That's fine. Okay, so that should actually make it repeat indefinitely, hopefully. Right, of course, X, yeah. So, comma somewhere, right? So I think it has to be... Init, the definition was here. So what do you want from me? Inline from here. More argument to the, did you forget it? No. What kind of arguments you want from me? So initialize, oh, you also have to supply the allocator. Okay, so we can just supply the heap allocator, I suppose, or whatever the current allocator we have. Make sure you can express. Is there like, so what about this arena? This arena is just like a continuous one. Oh, it sublocates within the fixed amount of memory. Okay. So, I don't think I want to use this one, at least for this case. Can I? Okay, so I suppose. But what if I want to customize it? I can put, you know, back allocator. Let's go backing allocator in here. Can you see what I'm doing, chat? Allocator. And I can by default just make it allocator heap, but then you can customize it if you want to. Backing allocator. All right. Okay, so that seems to be working. So that's pretty cool. And it cleans itself up. So it doesn't leak any memory, by the way. Right. So because it's going to be cleaning itself up every time. So, and hopefully it's going to be doing this kind of stuff forever. All right, let's fucking go. Let's try to run the whole thing, and let's try to connect in here. And hello, it returns hello. Let's connect the second one. Test, it returns test. And now let's take a look at that. There's no more threads. There is a spinning thingy-majingy in here, but there's no more threads. Right, 2 clients are working fine. Almost. Okay, something didn't repeat here properly, right? So, oh, okay. Okay, I see. So let me see what the fuck is going on. So probably something with the right future, right? So something definitely with the right future. So let's go ahead and fix that. Let me see. So right would block return null. So when we subtracting n, honestly don't see any problems, right? So it kind of worked fine, but it feels like it didn't recreate itself. That's what it feels like, chat. That's what it feels like. There's no chat, I'm alone. I think I'm going crazy. Right, so here is the forever. When we pull the whole thing, right, and it finished, we just set the future to null, and we just always return null. Okay. I honestly don't understand why it didn't work. Maybe I had to put something there? I didn't think so, actually. It should be done, shouldn't it? It should be just done. And then it kind of stuck at right in here, but we marked the client socket as non-blocking. That's for sure. So here we go. So we marked it as non-blocking. So that shouldn't fail. Writing shouldn't also fail. So that is bizarre. That is bizarre. I don't see any problems, but So what I can tell you is that we managed to receive it once. Okay, so let's try to reproduce it one more time just to see, and with a single client. Right, so it's going to be hello. We received it back, and then we can't receive the second one. So that means we get to maybe this point, to catch point, and we didn't. Oh yeah. So just recreate right and a catch. Let's not have a catch in here then. Maybe the catch actually obscures something. That could be the case. Maybe there is a bug in catch. Yeah, that would make sense, I suppose. I would expect that the error would also propagate through several thens. I think then is actually designed to propagate that error. So let's connect. Let's test. So it's definitely not about catch. So it's something about forever. Something about forever. So the environment in our case. And also environment, okay. Maybe this is because in case of a success, I return. Let me try to maybe print all of these things. Print fn, like log write d, and let's write that n. Right, so let's keep writing like how many of them it managed to write. So if let's close that, okay, I don't see any problems. Like it should just work, but hopefully I didn't get into any sort of write 7. Okay. We can actually put something like this. Put client disconnected like that. Right. So does it actually finish the thing? Does it actually finish? I feel like it's probably something very simple and probably something very subtle. Right, so okay, something very, very subtle that I just don't see. I just don't see it. Alright, and it didn't return after that. It just simply didn't return, even though it's supposed to return. It printed that. Right, it printed that. What if I also print d client n? Right, so let's actually print also d client n. Right, and it's 0. So that means when it is 0, it should return client, which effectively should then return out of here, but it didn't. So I don't know. It didn't properly return because it's a well, I mean, because it's a forever. Yeah, that makes sense. That makes sense. But then I think I know what the fuck is going on. I forgot to clean up I and N. Yeah. All right. I think yes. So I'm modifying the client state, but I do not properly reset it. Okay. So stupid of me. Anyway, and this is where, by the way, we can use this argument of this forever future, right? So essentially we can put it as a client, right? Who said we can't do that? We can do that. But that just means that, well, I mean, I need to have a pointer to that, mother flipper, somehow. But I don't have it yet. I just don't have it yet. But anyway, so we can actually do arg. This is the client, and within the client, what we want to set I to 0 and N to 0. But in all honesty, we can, yeah, so that's the thing we can do. So, and here in forever, we have to supply the client, but we are in the middle of defining that very client. So that's kind of stupid, honestly. So what we probably have to do, we have to have a client pointer client like this, and we probably have to move the definition of the future kind of outside of this entire thing. So we have the pointer to the client, right? So here is the future, here is the client equal to future, and as we're constructing, we also, well, yeah, that fucked it up. That's fine. I think we can fix that. Not here, but here. So, and there we go. So here is the client. We constructed it. We supplied the socket, but the rest of the stuff is 0 initialized. Then we set its future to be that indefinite loop. And we also provide client as that thing, and then we pass the client to here. Right, so then we say the client is disconnected or whatnot. So interestingly, right, so yeah, we put disconnected in here, and that should actually fix it. Yeah, so one of the important thing I forgot is to just do IN. Right, and that argument, yeah, that's what it is. Okay, cool. So let me try to run that, and I'm gonna open this thing, test, world, test, seems to be working. I can even open the second one, hello, test, everything's working. This one is still working. We are operating on a single thread. That's what we did. That's what we can do. So I would like to maybe make it a little bit prettier. Right, so maybe factor out some of this operation, because this could have been like literally a single function, right? So something like async read once, right? So, and let's actually put it like this. So this is the future, right? And yeah, so let's actually do it like that. So async read once, and should it accept anything, right? It definitely should accept the thing it operates on, but I'm not 100% sure, right? Async read once. Maybe we're gonna call it client, but because it expects the client in here, right? So it expects the client, right? And in here, instead of this kind of stuff, we can now, does it accept any arguments? No, it doesn't. We can now just call like async like client async read once. Then we can have something like client async like write, right? So let's actually put it in here. Fn future client async write everything, like, yeah, everything. Right, so let's put it like that. So we're going to return this entire thing. So, and this is the function that, yeah, we could have actually passed this thing to and then. Where is the forever? I didn't see forever here. So we could have actually passed it as, you know, and then write client async write everything, but then expects the results. But maybe we can actually have the result in here. But at the same time, it doesn't really matter because it uses that as a state. Maybe it can, okay, we can actually use that as a state of the future, right? To actually use it somewhere, but it doesn't matter. So I think I'm going to do it like that. So yeah, the main sort of difficulty with this library is going to be deciding what's going to be the state and what's going to be the environment. It's up to you. You have to manage the lifetimes and everything. Right, so now look. So you do async read once, then you do async write everything, And at the last thing you do, you're just trying to catch a potential error in there. And if you catch the potential error in there, you close the connection. We may also factor that out to a separate function, right? So something like client catch error, something like that. But it doesn't really operate on the client. But I mean, it operates on the client error, right? So we can do something like that. Client catch error, maybe even call it async catch error. Okay. Async catch error. And now we can actually boil this entire thing down to just that. Right, so here is the forever loop that loops forever, and on each iteration it resets I and N, right, and then it does client async read once, which populates the buffer and I and N, then async write everything that writes everything that was within the client, and then if there's any error, it catches them or propagates them and stuff like that. So essentially this is, if it compiles, by the way, I don't know if it compiles. It doesn't, of course, because I forgot the semicolon. Spent 3 hours debugging and it was just a single missing semicolon. Am I right? I swear to God, I must show you, chat. Chat, I must fucking show you. Right, just a second. Because I fucking hate it. I absolutely fucking hate it. So one day I was playing with LLMs and I just asked them, just write a tweet in Soding style. And both GPT-4o and Llama tell me the same fucking stupid programmer's joke that I absolutely hate. Right, just spent 3 hours debugging and it was a single missing semicolon. I absolutely fucking hate this joke because, well, I mean, it doesn't make sense in the modern setting, okay? So maybe in the past, there was such a shitty compilers that couldn't report shit properly, and also interpreters that you could spend 3 hours fucking finding semicolons. But these days, people spend a lot of time for, you know, reporting diagnostics, so it's not an issue. But people perpetuate this joke. And my hypothesis is that this is basically imposters who never done any actual programming, but they try to fit in because they're trying to get into tech. Right. They don't fucking understand what this actual joke means. They just saw that joke on Programmer Humor and they just repeat that joke because, yeah, I want to just fit in. I'm one of you guys. I'm a programmer. Right. So funny joke, funny semicolon joke. Haha. Right. And it pissed me off. And I then thought, okay, I'm gonna post that joke on Twitter. I'm gonna literally fucking post that. So look at these motherfuckers. Look at these imposter motherfuckers. Look at them. 2,647 imposter motherfuckers. I swear to God, it's such a stupid and irrelevant joke, and people still fucking repeat it. It's bizarre to me. It must be. Is that bots? It must be fucking bots. Like, what the fuck is going on? Anyway, I'm sorry. It's like I had to rant about that. Right, it's a missing semicolon, right? So look at that. Look at that. The missing semicolon. You forget the semicolon. Look, I can show you. Look at that. Fucking look at that. I found it in seconds. Fucking found it. Anyway. Sorry. What do we have in here? Expected function followed by and prefix. Motherfucker. I suppose, yeah. So if you want to, yeah, I suppose I have to do something like that, right? So otherwise it's not going to work. Yeah, no. All right, right. So, and let's also test it, right? So because who fucking knows? Maybe it doesn't work. Let's fucking go. Hello world. Hello world. Everything works. Okay, cool. So let me now show you. Let me now fucking show you. So here is the essentially synchronous version of the code. And it's a while true, read buffer, write buffer, repeat. Read buffer, write buffer, repeat. If it's equal to 0, break out of that. Cool. So similar thing in here. Absolutely fucking similar thing in here. So basically read once, write everything, catch error. Honestly, it will be kind of interesting to actually do something like Yeah, equivalent of like break, like of if equal to end break. That would have been kind of cool. Let me try that. So essentially, don't try to check that at read. Right. So just read once, and whatever you manage to read, just return that. When you're writing, or maybe in case of writing, it's going to be kind of weird. Yeah, just write everything until you finished writing. Nah, I don't think it's gonna work. So let's actually abandon this idea. For some reason my Emacs doesn't work. Yeah, I was thinking that maybe I can just like then at the end in this future somewhere I could have a function, right? Instead of this function, I could have something like client, and if the client n or I is equal to 0, that means it closed the connection, but it's kind of difficult to pull off, and I can do that, but not on the stream, right? So it doesn't really matter that much. So what we need to do, I think that's basically it, right? So let's introduce some sort of a, how is it called? Some sort of flag, right? So I want to actually flip-flop between different implementations in here. So let's introduce something like async, which is going to be a boolean, and initially it's false, right? So if we are in a synchronous situation, right? If we are in a synchronous situation, we want to initialize all of this stuff, right? So we are in a sync. So set non-blocking, do this entire feature stuff, right, and just do it like that. So this is end if. So, and in here, we can switch between them, right? If async, we do that, right? So we do that logic. Otherwise, if it's something else, we do multi-threaded version, right? We do multi-threaded version. So can I close it like that? All right. Alrighty. Sorry. So does this compile? Doesn't compile. 138. What's up with that? Clone. Something, it doesn't like something about the client. Is that because the client is... What was the client? I suppose it was a client socket, was it not? Yeah, I see. It was a client socket, and we were accepting it in a very specific way. Let me try to do that. So that's how we were accepting this entire stuff. Right, the accept kind of evolved out of this entire thing. So, and I called it client, and also now we kind of, yeah, we kind of have a server socket. Right, so server socket like that. And I suppose it's going to work now. Okay, so that seems to be working. And might as well also do client sock now, for the sake of consistency, you know. So this is a client sock. Let me just query replace client sock, like this. Boom, 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 not boom. All right, so let me see. Hello. All right, and if I try to do that, okay, so that's pretty cool. Okay, so I think I want to do a little bit of intro. So in the last stream, I actually did a pretty cool thing. I did a sort of like a preview intro, and it kind of actually improved the engagement and stuff like that. So maybe I'm gonna actually intentionally start sort of like recording these intros that I put at the beginning, right, to sort of like, you know, warm up people for what they are going to expect. Right, and yeah, so I can actually just basically demonstrate you. So essentially here we are not in a SIG. So, okay, let's actually run, one more time. Let's actually run a non-asynchronous version, right, and we can connect to it, and yeah, as you can see, it is responding. We can connect to like through a different client, and it is responding as well. But look, the problem here is that it creates two separate threads. And every time I do another connection, it creates another freaking thread. But now let's take a look at our asynchronous version. Let's kill this shit and let's put asynchronous true. There we go. Let's actually run it, and I can connect to that. It responds to any of my queries. I can connect another one. I can connect another one, and all of them are responding. Nothing is blocking. Everything is perfect. But look at that. There's only one single thread in here. There's no additional threads. There's no additional threads in here. It's all handled within a single thread because we're using asynchronous sockets. That's right. So that's basically going to be the intro. It's actually kind of cool that it just like all of them disconnected when I killed the server. Right, and this is going to be our example in here in the library, in the futures library. Right, and yeah, it's going to come with the library. So you can just study it and stuff like that. Maybe at some point I'm going to refine these primitives, like an ability to asynchronously read things and asynchronously write. Right, and the main goal of this entire library is to eventually incorporate all of that stuff into the WebSocket library that we have also in C3. WebSocket library that we have in here, it's a synchronous library, right? It's feature complete, essentially. It's up to spec, right? It passes the, Autobahn test suite, right? Which is very harsh, like fuzzing suite. It passes them with the flying colors, but it's synchronous, right? So it's kind of difficult to use it in real world, unless you do multi-threading. But with multi-threading, you have all sorts of problems, right? So I want to make it asynchronous, and basically I'm developing libraries specifically for that, and it's going great, I think. So it's rough around the edges. I still haven't refined some of the part of the interface, right? So the idea of state versus environment with different lifetimes and stuff like that. But honestly, C3 kind of makes it easier, right? Honestly, because it introduces this concept of any, which is basically the thick pointer, right? So in languages like Rust, you have to always play this type Tetris. Where with the types of futures fit or not fit, and it's just like a lot of time. But sometimes you kind of want to say fuck it and just like program in a toy scripting language, and C3 actually kind of allows you to do that with any and stuff like that. And to be fair, any is not that big of a runtime cost in a sense. I can implement any in C, because again, it's just a structure with a tag and a pointer, right? So you can do a similar thing in C as well. In fact, something like a libcello is basically that any, but in C. If you want to learn more about like libcello and like what this library is all about, I did a stream where I explored this library. It's actually a very cool library, and it has the var type, which is basically any in C3. And any, as far as I know, like I think Jai introduced any first, right? If I'm not mistaken, right? It introduced any first, which is a structure of like pointer and a tag. So yeah, I guess that's it for today. Thanks everyone who's watching right now. Really appreciate that. Have a good one, and I see you all on next recreation programming session with Mr. Azuzin. I love you. Mwah. Alright, this is the next day, and I was cleaning up the library and I noticed a very nasty bug that I somehow missed. So if you try to run the server, right, and then try to connect it, everything's fine, it is responding. But then, if I try to close the connection on the client side, the server goes into infinite loop, right? So it's kind of stupid, but essentially, we need to change where we catch things, right? For example, here is an infinite loop. And we read things asynchronously, and then we write things asynchronously, and then we're trying to catch an error that may happen in any of those, right? So, and an error could be that the client is closed, right? This specific error. This is what we're trying to catch. You have to catch it outside of the loop, because when the error happens, we have to quit the infinite loop. Catching it inside doesn't quit the loop. Right, so you have to move the catch outside of the forever, and only then it is going to close properly. Somehow I just missed that, right? So I can do this kind of thing, and then I close the stuff, and it's disconnected. For some reason it says it twice. Maybe I have some extra printing somewhere here. Yeah, so Here's one, here's another, and I probably can remove this one. So there's an extra printing of client disconnected. Right, not that critical though. Right, so close everything, disconnected. All right, that's it for now. Right, thank you so much.